So in assignment number 2, we simplified radical expressions. And in this assignment, assignment number 3, we're going to be multiplying and dividing radical expressions and then simplifying. We're also going to be rationalizing the denominator in several different ways. And so let's go ahead and get started with this and see how we do. So we're going to start with radical 3 times radical 12. This is something that you did in Algebra 1. We can actually multiply these radicals together. Radical 3 times radical 12 is radical 36, and the square root of 36 is just 6. And so number 1 simplifies to just 6. As we do each of these, you might want to pause the video, try them on your own, and see if you can figure them out, and then make sure that you have it correct. So for example, you can try number 2, the third root of 3 times the third root of negative 9. Hopefully you've done that. If you've done something like this, you would get that that's the third root of 3 times negative 9 is negative 27. And the third root of negative 27 is simply negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. So we're off and rolling here. We're going to have some problems get a little bit more difficult as we go, though. So here we have a single radical. We're going to try to simplify the cube root of 54x to the 4th y to the 3rd. So we're going to start with the cube root of 54. So maybe we can do a factor tree of 54. We know that 54 is 27 times 2. 27 then is the same thing as 9 times 3. And 9 is 3 times 3. And so we're going to pull these factors out in groups of 3. And we have 3 3's here. So that means we're going to have a 3 on the outside. And then inside the radical, we're going to have this 2 left over. So that's the cube root of 2 left over on the inside. That's the number part of this. And then we have the 4 x's here. We're going to take them out in groups of 3. So we have one group of 3 and then one x that has to remain inside the radical sign. Then we have 3 groups of y, or we have 3 y's. We're going to pull them out in groups of 3, which is all 3 of them. And so we have a y on the outside. And so number 3 simply looks like this. No absolute value signs that we need to worry about because our index here is 3. It's not an even, odd situation. So it's just 3x times y times the cube root of 2x. Let's move on to number 4. So now we're multiplying 2 radicals together. I think what I'm going to do here is multiply everything that I can multiply together first. Like for example, I can multiply the actual numbers together. 3 times 2 is 6. Then I can multiply the stuff in the square roots together, like 7 times 21. 7 times 21 is 147, I think. X to the 3rd times x to the 3rd. Well, we go back to the product property. We're going to add those exponents because they're like bases. That's x to the 6th. And then we have y to the 2nd. And so now I've written this as a single radical expression. And so now what I'm going to do is simplify it by taking the square root of this radical. So the square root of 147, I want to simplify 147. Of course, we know that that's 21 times 7. And then 21 can be 7 times 3. So I'm going to take out a pair of 7's here. And so the 7's going to be outside with the 6. And 6 times 7 is 42. Then I have left over inside the radical sign, I still have this 3 here. And so then I want to take out as many of this x's as possible. I'm taking them out in groups of 2 here because this is the square root. So I have 3 groups of 2 to take out. That's an x to the 3rd. And I have y squared. I'm going to take out both y's. Okay? So because I have groups of 2 here. And so you can see here this is an even and turns into an odd in both situations. And so I'm going to put absolute values around both of those. I could put the absolute value around each one separately, or I could put it around each one like I have it here. So a lot of times, and I think in your homework it might say assume all variables are positive. And if we assume all variables are positive, then I wouldn't need the absolute value bars at all. But if we don't assume that, then that's where our absolute values would be. And so it's simply going to be 42x to the 3rd times y times the square root of 3. All right, let's move on here. Number 5. So what I'm going to do here is divide these. 12 divided by 3 is simply 4. So this is the square root of 4. And x to the fourth, this is x to the first down here. I could subtract those if I use the quotient property. 4 minus 1 is x to the third. And so then I'm going to take the square root of 4 is 2. And I have 3 x's here, but I'm taking them out in groups of 2. So I get one pair of x's that's on the outside. And then I have 1 x left over. And so I'm going to have 2x times the square root of x. And from this point forward, we're just going to assume that all radicals are positive, and so or that all variables are positive, so we won't have to worry about the absolute value bars. Let's take a look at number 6. And again, what I'm going to do here, I could think about this as one big fourth root, and that way I wouldn't have to do them separately like we have here. And I'm just going to simplify 1024 over 4. And I'm going to write this as a single fourth root. 1024 divided by 4, well, I know 1000 divided by 4 is 250, so that's going to be 256. And then x to the 15th over x to the first is x to the 14th. And so now, since I simplified this as one simple radical, now I'm going to simplify this radical. So 256 divided by 4 is 64. And I know that 64 is 8 times 8. So that's 4. This 8, I'm just going to do it like this, is 2 times 2 times 2. This 8 here is 2 times 2 times 2. And this 4 is 2 times 2. So how many groups of 2's do I have? How many groups of 4 2's do I have? Well, here's a group of 4 2's, and here's a group of 4 2's, and so that's a 2 times a 2 on the outside, which is a 4 on the outside of my radical sign. In other words, the fourth root of 256 is 4. And then I want to figure out how many groups of 4 x's can I pull out. I have 14 x's, and so that's going to be an x to the third on the outside because that's 3 groups of 4. That's 12 of them. And then I have 2 x's left over inside the radical sign. And so, again, here I have an even and an odd situation. I'd probably need to put absolute values around the x to the third. But if we assume that all variables are positive, then I don't have to worry about that. So my final answer here for number 6 is 4x to the third times the fourth root of x squared. Hopefully you're doing these prior to me doing them to see if you're getting them correct and not just copying down what I have. Let's try number 7. We want to rationalize the denominator here. Really, there isn't anything to simplify here. I can't simplify 3/5 as a fraction, and I can't simplify the square root of 3, and I can't simplify the square root of 5. I could write this as the square root of 3 over the square root of 5. But both of these forms are bad. It's bad form to have a fraction inside a radical sign, and it's bad form to have the denominator as a radical. So what I want to do is take this radical 5 here and make it a rationalize that. And we do that by multiplying the top and the bottom by the square root of 5. If I do that, then the square root of 3 times the square root of 5 is the square root of 15. And the square root of 5 times the square root of 5, well, that's the square root of 25, which is just 5. And my final answer is going to be the square root of 15 over 5. So now my denominator is a rational number. So how do I do that on something like number 8? Well, let's start by simplifying number 8. I can write this as 2 over 10 reduces to 1 over 5. And then, so I have the square root of 1 on top, square root of 5 on the bottom. But then x to the third over x to the first is x squared on top. And I have a y on the bottom. Well, the square root of x squared is simply x. But then I have the square root of 5y on the bottom. So I'm going to simplify that. I'm going to rationalize the denominator by multiplying both the top and the bottom by the square root of 5y. So if I do that, the numerator is going to be x times the square root of 5y. And in the denominator, I'm going to have the square root of 5y times the square root of 5y. I could write that as the square root of 25y squared. But the square root of 25 is 5, and the square root of y squared is just y. So my final answer is going to be x times the square root of 5y over 5y. Let's try one more problem here. Again, I'm going to start this by simplifying the cube root of 4 over the cube root of 6x. Well, the 4 and the 6 can simplify to this. It's the cube root of 2 over the cube root of 3x. But because this is a cube root, it makes it a little bit different. I can't just multiply this by another cube root of x because I need 3 of them. A cube root of 3x because I need 3 of them. What I'm going to have to do is multiply this by the cube root of 3x and another cube root of 3x. And I'm going to have to do the same thing with the numerator. And the reason I'm needed to do that is because it's the cube root. If I multiply everything on the bottom together, I'm going to get the cube root of 3 times 3 times 3 is 27. X times x times x is x to the third. The cube root of 27 is 3, and the cube root of x to the third is 3x. So my denominator is now 3x. But my numerator, I'm going to have to multiply all 3 of these things together. So that's going to be 2 times 3 times 3. Well, that's the cube root of 18. And then I have an x and another x. This should be x here too. I have an x squared. And so, see if I can simplify the cube root of 18. I know that 18 is 9 times 2, and 9 is 3 times 3, but I don't have a group of 3 of anything. So it's just going to be the cube root of 18 x squared over 3x. And that is what my final answer is going to look like for number 9. So it's a little bit different when you have a cube root. You're going to have to multiply it times 3 factors because it's a cube root and not a square root. And that's how we're going to rationalize the denominator. These are the kind of problems that you're going to have on your homework assignment for tonight. Good luck with them, and we'll go over them more tomorrow in class.